Hello students, the next topic is digital signaling format, that is regarding line codes. Number one, depending upon the duty cycle of the pulse, how it is classified. So given the sequence of pulse, there are two possible waveforms. One the NRZ, ಇನ್ನೊಂದು RZ. NRZ means non-return to zero format. If the transmitted pulse waveform, it occupies full duration of the symbol, then we call it as a NRZ, non-return to zero format. A second RZ is if the transmitted pulse waveform it only occupies a fraction, that is usually half of the pulse duration, then it is called return to zero, that is RZ format. And second classification is depending upon the polarity. So given the sequence of pulses, there are three possible waveform format we can use to send. So otherwise three types will be there depending upon the duration, say TB seconds over the channel, and based upon the polarity of the pulse. We have unipolar, polar and bipolar formats. So these are three different types. Next concept is digital modulation techniques. So digital modulation techniques, they are used for sending the binary information on the analog carrier. So information is binary but carrier is analog. BASK, binary amplitude shift keying. So this signaling scheme, it was one of the oldest or earliest forms of the digital modulation techniques which was used in the wireless, that is radio telegraphy, at the beginning of the last century, and it is the very simplest form of the communication digital modulation techniques, and it is sometimes called OOK, on off keying. And second one is a BFSK. It involves switching the frequency of the sinusoidal carrier in between two values, say F1 and F2, in accordance with the incoming binary data, while keeping, point to be noted, while keeping amplitude and phase are constant. BPSK, binary phase shift keying, this PSK, it involves switching the phase of a sinusoidal carrier in between two values, say Q1 and Q2, in accordance with the incoming binary data, while keeping the amplitude and frequency constant. And it mainly uses two phases which are separated by 180 degree and is also termed as 2 PSK. Next topic, multiplexing. Many into one, that is MUX. Multiplexing means the process of simultaneously transmitting two or more individual signals over a single communication channel but without any interference. So with the help of multiplexing, what we can do, more information can be transmitted, and this multiplexing makes the communication system more practical, and there are and this will be a savings of money. And FDM, frequency division multiplexing. FDM and TDM are two types of MUX. FDM, what happens in frequency division multiplexing, a number of signals share the bandwidth of a common communication channel. One channel, one common communication channel, okay, is used, and here the number of signals, they are going to share the bandwidth of the one common communication channel. So there is a sharing of bandwidth of a channel. In case of TDM, here each signal, it can occupy the entire bandwidth of a channel. Each signal is going to occupy the entire bandwidth. However, and each signal is transmitted only for a short duration of time, a brief period of time. Next, multiple access techniques. So multiplexing means it's a technique in which several signals are carried in the single communication channel without interference. And the cable TV system is a best example for multiplexing. And multiple access, it is a multiplexing technique in which the signals to be multiplexed originate at different locations, and the simplest multiple access scheme is the one which is used by radio and TV broadcasting stations. And there are three types of multiple access techniques: FDMA, TDMA and CDMA. And there are two important types of spectrum systems we have. One is FHS and second one is a direct sequence. Frequency hopping system. Here what happens in this system, a frequency synthesizer is used to generate the carrier. We are using the synthesizer, and that synthesizer is going to generate the carrier, and this synthesizer, what it does, it is going to change the frequency many times per second according to pre-programmed sequence. And this sequence is also called PN, that is pseudo random noise sequence, PN sequence. And second one is a direct sequence system, DSS. In here, the direct systems the direct sequence system, it is used with the digital modulation scheme such as PSK. The next topic is transmission media. So media is mainly used to send the signals. We have a transmitter, we have a receiver, in between there is a media or a channel. It may be wired or it may be a wireless. We see we'll go through this. Media are of two types: guided media, unguided media. Guided media, we have a twisted pair cable, coaxial cable, fiber optic cable. Again in twisted pair we have a unshielded as well as shielded and coaxial as it is, and we have a fiber optic cable that is OFC cables, multi-mode step index, single mode step index, and we have a multi-mode gradient index. Whereas in unguided, it's wireless, terrestrial microwave and satellite microwave. This is regarding the classification of transmission media. And next, there are three important types of guided media: twisted pair, coaxial cable, and OFC cable. First one is a twisted pair cable. Here it is a cable which is used for telephone system, and it is mainly used to connect the terminals as well as and it is a low speed data equipment. And there are two varieties of twisted, UTP and STP. UTP is an unshielded twisted pair. It is the most commonly used medium in the telephone system. It can carry voice as well as data, especially in office buildings, etc. And there is a no shielding, no protective jacket is covered. So this is a shielded twisted UTP, unshielded twisted pair. And the other one is a shielded twisted pair, STP cable. Here in this cable, the twisted pair is covered by the metal shield and finally by the plastic cover. There is a cover, there is a jacket, and this metal shield, what it does, this metal shield, it provides immunity to the penetration of electromagnetic interference as well as a crosstalk. So ಏನು ಮಾಡ್ತೈತೆ, the shield ಇರೋದ್ರಿಂದ interference and crosstalk ಅನ್ನು reduce ಮಾಡ್ತೈತಿ. And next we have a coaxial cable, which is nothing but your cable TV cable, and this cable consists of the center. We have a copper conductor surrounded by a surrounding insulation such as Teflon coating, and it is in turn surrounded by the tube shaped conductor of a solid copper or solid aluminum or metal braid, and outer plastic jacket is there which protects the insulator braid. And this outermost tube and the center conductor, they are going to share the same common axis of curvature, hence the name coaxial. All the things, they are going to share the same common axis, hence the name coaxial cable. The typical characteristic impedance are 50 ohms and 75 ohms. The cables, they support higher data rates, long distances and greater durability. Next one is OFC cable. Fiber optic communication system is a one in which light is mainly used as a carrier for the information transmission, and cables are used for the purpose of transmitting information on the light beam over very long distance. So it is mainly used to send the signals for long distance communication at a speed of light, and this cable provides highest data transfer rates, that is gigabits Gbps, less susceptibility for the transmission errors, as well as there is a protection of electromagnetic interference. So there is a immunity for the interference, and it is very expensive, no doubt, and more difficult to install compared to other cables. But initial capital cost is also high. These fiber cables work on the principle of TIR, total internal reflection, and these fiber optic cables, they may have a glass core with a glass cladding, or it may be a plastic core with a plastic cladding, or it may be having a glass core with a plastic cladding, that is a mixture, and it is called PCS, that is plastic clad silicon ಅಂತ ಕರೀತೀವಿ, because the glass has the lowest loss, but it's a very brittle, and the plastic is very cheaper and more flexible but has got high attenuation. So we have a plastic clad glass PCS. And mode means which refers to the various paths that the light rays can follow. In case of multimode ಏನಾಗ್ತೈತಿ, the light takes many paths through the wire, and in this case LED is the light. So LED is a light emitter device, and number of modes supported by this one single fiber can be in the range of 1 to 1 lakh. So in case of single mode, the light follows a single path through the core, and in this case laser is a light source. So we can use the laser here in this case, and based upon the RI, that is a refractive index variation, and the mode fiber optic cables, we have a classification: multi-mode step index fiber, single mode step index fiber, multi-mode graded index fiber. multi-mode step index SI. Here the multi-mode means the use of LED as a light source, and step index means it refers to the fact that there is a sharply defined step change in the index. So the step index means the index is sharply defined, but it is of a step shaped index where the fiber core and the cladding they are meet. When there is a meeting of a fiber core and cladding, there is a step change. And we have a single mode step index fiber cable. Here single mode refers to the use of laser as a light source, multi-mode is LED, and single mode we have a laser as a light source, and it is going to provide highest data transfer rates, and it is most expensive configuration. And multi-mode graded index fiber cable, this multi-mode refers to the use of LED as the light source, but in case of graded index cable, the index of refraction of core, it varies smoothly and continuously over a diameter of the core. And so these are three types: multi-mode step index fiber, single mode step index fiber, multi-mode graded index fiber cable. There are three varieties. And what is attenuation? Definition: attenuation is nothing but the loss of the optical power as light travels along fiber, and the energy losses and the signal degradation in the fiber is attributed to absorption, scattering, bending, etc. And the unit of attenuation is decibel per kilometer. Okay. And what is our refractive index of the medium? N equal to C by V, where N is our refractive index, C is the velocity of light in free space, and V is the velocity of light in the given medium. And average information signal, this is regarding information theory formula, H is equal to summation I equal to MPI log of 1 by Pi, and the channel capacity is denoted by this formula, and Shannon-Hartley theorem is given by this formula. And this is regarding UTP category 1, 2, 3, 4, 5, and we have the types of common communication, the voice bar data, or the first category 1 is a voice, and second 2, 3, 4, 5 categories are voice as well as data, and this is a data rate in Mbps, megabits per second. So this is regarding your DC. In the next video we shall continue the new subject.